Hello. In today's video, we're going to be talking about mixtures. Mixtures are important because almost everything you're going to encounter is going to be some sort of mixture. It's really hard to get just pure substances, but mixtures themselves are going to be the combination of two or more pure substances. And if you've forgotten what a pure substance is, these are going to be our elements, molecules, and compounds. Okay. Our mixtures themselves can be heterogeneous or homogeneous. Homogeneous mixtures are going to be ones that are going to be uniform in appearance. So you can't see the parts of the mixture. On the other hand, heterogeneous, you can see the different components of the mixture. So this is where distinct components can be seen with the naked eye. Boop. There we go. Okay, so let's go through this little flow chart and see our different components of our different type of mixtures. So with mixtures, as I said, they can be homogeneous, which includes solutions and colloids, or they can be heterogeneous, which we call that a suspension. Within each, we have different components. We have different particle sizes and we have different appearances. So we're going to go through all of this. With a solution, our major component, the thing that is in the greatest quantity, is called the solvent. And then our minor component, what's in lesser quantities, is going to be the solute. You will only ever have one solvent. You can have multiple solutes, however. With a colloid, you're going to have the major component being called the medium. And then the minor component is called a colloid. And then with the suspension, the major component is again called a medium. And the minor component is called a particle. Okay. The only one that's really considered a dissolving process is a solution. The other two are where we can just either homogeneously mix or heterogeneously mix the thing throughout. And with a colloid, it will suspend in there. It will stay suspended indefinitely. With the suspension, it'll, oddly enough, not stay suspended indefinitely. It will eventually settle out with the help of gravity. And this has to do with our particle size. So with a solution, that particle size is going to be less than 1 nanometer. Okay? And our particle is our solute, right? And that means that it is a molecule. With our colloid, it's going to be 1 nanometer to 1 micrometer. And the colloid itself can be one large molecule or a conglomeration or group of molecules together to form a larger size, which is why it doesn't actually dissolve. And then lastly, our suspension. This is going to be greater than 1 micrometer. So this is either going to be a very, very large particle or substance like a blood cell. Or again, a agglomeration of a bunch of molecules together to make this particle. So colloid and suspension, generally we're not talking about small molecules being in here. Or if we are, the small molecules have made a colloid or they've made a particle, so they've made a very large sized thing that goes in and gets either suspended indefinitely or suspended for an amount of time. With our substances, or different types of mixtures, we're going to have different appearances based on the fact that we have different particle sizes. With our solution, since we have very small particles and they're dissolved and homogeneously mixed, these are going to be clear or transparent. Clear and transparent. Not necessarily colorless, but clear. With a colloid, it's going to be cloudy. Sometimes you can't really see the cloudiness unless you actually shine a light through it that will actually refract off of the particles in there. But it does have a uniform appearance. So you can't see a distinction between the substances. And then lastly, our suspension. This is going to be cloudy as well. But we're going to we can see two substances. And eventually the particle will settle out. Okay. We are going to focus mostly on solutions. So, real quick, look at a solution. So, solutions, they are going to have a constant composition. Okay. And when we form these, no chemical change occurs. In just a minute, we'll look a little bit more at that. We do have physical properties of solutions changing a little bit. So the physical properties of the solution are similar, but not exactly the same. And we'll talk about this in a little bit, what we call these colligative properties. So when we talk about colligative properties, we'll get back to the change in our physical properties of our solution versus our solvent. Okay. Another thing to note about solutions are solute and solvent don't need to be in the same state of matter. But our solution will be in the same state of matter as our solvent. Okay, let's look at a couple of examples of solutions in all three states of matter, because we're going to have all three states of matter existing within our solutions. Okay, we already talked about last chapter a solid solution, which is probably the first time we'd ever heard of that, but we'll look at all of those. So we're going to look at solvent-solute combination. So if our solvent is a gas, the only option we have for a solute that is a solution is a gas. So this is going to be like the air that we breathe or the air in a diver's tank. We cannot have a solution where the gas is a solvent and we have a liquid or solid solute. So these are going to be Na for both of these. We can form colloids or suspensions with liquid solutes and solid solutes mixed in with gas, but not a solution. if we dissolve a gas into a liquid, we get soda pop, right? So the carbon dioxide in there. We also have gas and liquid in blood. Okay. Blood itself is not a solution, but the gas in water that we see in blood is the part of the solution that we're looking at. A gas dissolved in a solid is also an option. We see this with H2 gas in palladium metal. Okay. If we want liquid, there is several options for this. Alcohol. Any alcohol. We usually have ethanol dissolved in water. Antifreeze. Another example. Liquid dissolved in a solid. Mercury dissolved in gold. Another example is if we have enough water dissolved in salt, or enough salt with water in it. So if we have a hydrated salt. Solid solute in a liquid solvent. This is also another very common thing. Kool-Aid. Right? Any sugary drink, basically. And salt water. The ocean, if we were to filter it out. And then our solid solutions, where we have solid solute, solid solvent. Brass is an example of this. Pewter. So many of our alloys, stainless steel. So lots and lots of examples of that as well. Okay. So let's look a little bit more at what it means, or what solubility means. So solubility is a term we will use a lot. So we can talk about solubility as kind of just an idea, and that means how readily something dissolves in, or how readily something dissolves. So taking like a qualitative approach to solubility. We can also talk about it as a quantitative thing, as the max amount of solute that can be dissolved in a given amount of solvent at a specific temperature. It has to be given at a particular temperature because solubility changes with temperature. Mostly at higher temperatures we have greater solubility, but not always. So we will look at cases where solubility decreases at higher temperature. And just in general, we consider that everything is soluble. To some degree. Okay. When we're looking at solubility, we can compare it to a reaction. So this picture right here depicts a reaction. We add nickel metal to hydrochloric acid. Nickel reacts with the hydrochloric acid. When it does, we produce nickel chloride. and hydrogen gas. There's generally an associated color change that is not associated with either the color of the solute or solvent. So that will occur a lot of times, and there'll also be the evolution of gas in this reaction. So those are two common ways that you can see, or you can tell that something other than dissolution has occurred. So if you get a color change or evolution of gas, evolution of a significant amount of heat, those are usually indicative of actually doing a reaction. So dissolving is going to be when molecules and compounds interact via intermolecular forces. IMFs, intermolecular forces. So attraction between the solute and solvent particles. And this is forming a solution. What this does not occur is a change in identity. So there is no change in identity. Of the substances. Okay, so solution, we don't change chemical identities. We generally consider this to be a reversible process. So we should be able to take our salt water, drive off all the water, and get back regular salt. A reaction, this is when we have a process involving the rearrangement of atoms to produce a new substance. Or substances. So here our chemical identities change. And we usually consider this irreversible. But not always. Remember, we have equilibrium. Equilibrium is a reaction, or some reactions are equilibrium processes, which would be a reversible process, right? And also, you can sometimes add energy to cause a reaction to go the other way. Okay, so that's it for this lecture. See you guys later.